Some 340 kilometers west of Bangalore, capital of India's sixth largest state, Karnataka, lie these mountain ranges on the southern reaches of the Western Ghats. The highest peak of this range, at an elevation of some 1,900 meters, resembles a horse's face, which translated into the local language Kannada is Kudremukh, hence the name of the place. Kudremukh has an ancient history, which goes back to the days of the Ramayana. When Hanuman set out in search of Sita, he was advised to seek her, among other places, in Ayomukh, rich in minerals. In modern times, iron-bearing formations were identified here in 1913 by the late Sampath Iyengar, geologist of the state of Mysore. After Mysore was reorganized as Karnataka in 1956, further geological investigations were conducted in 1963-64. India ranks 4th in the world in its iron ore reserves after the USSR, Brazil, and Australia. These reserves are estimated at more than 21 billion tons, sufficient to meet domestic needs and for export for many years. In southern India also, iron ore is found, but the Kudremukh ore is of low grade. In the series of magnetite quartzite deposits situated along the southwestern coast, the southernmost ore bodies contain more magnetite. To the north and extending into the territory of Goa, the deposits contain more oxidized ore and are of a higher grade. The lower grade ore here, containing some 37% iron, remained undeveloped until recent advances in technology made it possible to process the low-grade ore. It was found uneconomical to process the low-grade iron ore for domestic use. So, the best way to exploit this national resource was to enrich the ore and export it to countries in need of iron ore. In early 1966, the National Mineral Development Corporation, NMDC, a Government of India undertaking, acquired the Kudremukh iron ore reserves. It covered an area some 6 kilometers long and 800 meters wide. In December 1968, the NMDC commenced an 18-month program, including pilot plant testing, jointly with an American company and a consortium of 3 Japanese companies. A feasibility report was prepared. It recommended an annual production of 7.5 million metric tons of iron ore. It also recommended the transportation of this ore in slurry form to the nearby port of Mangalore. The slurry was to be carried in slurry tankers to Japan. But the consortium pulled out of the project in 1974, and the Indian government started discussions with the Iranian government. Iran agreed to provide a loan of $630 million towards the cost of the project. Under the agreement, Iran was to buy the entire iron ore concentrate mined here for a period of 20 years at an average rate of 7.5 million tons a year. This was in 1976, and the first shipment of ore was to be made in August 1980. The entire project had to be completed in just 4 years. This was a challenge which was intimidating, but it was accepted. In April 1976, the Kudremukh Iron Ore Company Limited was established as a public sector undertaking to be administered by the Union Ministry of Steel and Mines. After shopping around the world, a Canadian company, Metchem, were retained as consultants. They were entrusted with the job of planning, designing, detailed engineering, procurement of services, supervision of construction, erection, projection management, start-up and operation of the plant during the first 3 years under the overall supervision of Kudremukh Iron Ore Company. Associated with Metchem were a number of Indian companies to do the detailed engineering, like Mekon, Engineers India Limited, Jayaprakash Associates, and Ho India. The corporate head office in Bangalore became a beehive of activity. In order to speed up the procedures and decisions, hotlines of communication were established between Bangalore and Montreal, where Metchem had their headquarters. Hotlines also connected Bangalore with the project site at Kudremukh and Mangalore port. The working force was quickly assembled from the steel projects already established in the country. These persons were highly skilled and were backed by years of experience in setting up and running sophisticated steel plants in the country. The following animation sequence shows the entire process involved in the project. The crude ore, with about 37% iron content, is drilled, blasted using up to 100 tons of explosives at a time, and loaded by shovels into dumpers for transportation to 2 gyratory crushers located separately. The crushed ore goes over conveyor belts to the Monsoon stockpile, where it is screened between coarse and fine. Through separate conveyors, the coarse and fine material is conveyed to the silos in the concentrator plant. From silos, the ore is fed into 4 autogenous mills, each mill linked to a pair of 1 fine silo and 1 coarse silo. In the autogenous mills, which are large rotating drums, the coarse ore and the fine ore tumble around with water and get ground. From the autogenous mills, the ground ore passes to the magnetic separators, where the magnetite portion of ore is separated. The magnetic concentrate then passes through ball mills for further grinding and recycling. The residual non-magnetic ore obtained from the magnetic separators passes through gravity spirals, where the major portion of the non-magnetic ore is recovered. The spiral concentrate is also reground in separate ball mills. The reground concentrates from magnetic and non-magnetic circuits are combined to obtain a concentrate of 66.5% iron. The waste ore, called tailings, is pumped to an earthen dam across River Lakya for storage. The final concentrate is pumped to a height of about 35 meters onto the 67-kilometer-long slurry pipeline to Mangalore, where the slurry is filtered and stored. For shipment, the material is reclaimed and fed through large conveyor belts to the ship loader for loading into ships. Since the whole project had to be completed in just 4 years, the planning had to be meticulous. The first concern was logistics. All the sophisticated equipment needed for setting up the project had to come from the nearby port of Mangalore. A road was there, but it was 172 kilometers long and not capable of carrying heavy loads. So, a decision was taken to build a new 8-meter wide asphalt highway designed to carry loads up to 100 tons between Mangalore and Kudremukh. This would also shorten the distance to 110 kilometers. The task was entrusted to the Karnataka State Public Works Department. But considering the stupendous task of construction of a highway through the thick Bhagavati forest, other organizations were called in to help. The Border Roads Organization helped in constructing some difficult stretches of the mountain road. It constructed 18 kilometers of road in the Mallur Ghat section, along with 9 minor bridges. The construction agency of the Indian Railways undertook the task of constructing 4 bridges in the same stretch. All this helped in getting the highway ready by February 1978. The completion of the road in record time was not only a tribute to the expertise of the various agencies, but also a tribute to the coordination by the project authorities of the work of these agencies. While the road was being built between Kudremukh and Mangalore, work was going on in full swing at the project site. A notable feature of the project was the simultaneous planning and execution of several activities. The early work was basically one of laying down the best foundations for the major components of the project, for the concentrator plant, which would be the heart of the project. For the giant silos, which would feed the concentrator plant. For the crushers, which would feed the silos. For the monsoon stockpile, which would ensure a steady flow to the silos. Warehouse, which would feed the project with all the spares and essential equipment readily and expeditiously. One of the problems tackled by the project right in the beginning was that of pollution. The ultimate waste in the pre-beneficiation process, known as tailings, had to be disposed of properly to avoid pollution. So, a dam was needed near the concentrator plant. This was planned across Lakhya, one of the tributaries of the Bhadra River. An urban dam connecting 2 hills, which would create a huge reservoir where the waste would be dumped. The catchment area would be 20 square kilometers, with a water spread area of 2.7 square kilometers. The dam itself would be 600 meters long and 65 meters high. The width of the dam at the bottom would be 313 meters and at the top 7 meters. The total storage capacity would be 63 million cubic meters of waste, technically called tailings. This would be enough for the first 10 years. Later, the existing dam's height could be raised or another built. The reservoir would also be a source of water needed at the ore concentrator. There would also be iron ore waste washed on the mountainsides during the mining operations. So, 2 mini dams were planned to prevent this iron ore waste from flowing into the Bhadra river system. Along with the work on the Lakhya Dam, one of the first things the project undertook was the provision of housing for the staff working on the site. Providing all the amenities of life in an area which was earlier practically cut off from the rest of the world was by no means an easy one. Even before the Kudremukh project was started, when the NMDC acquired these iron ore reserves, the regional inhabitants had to be rehabilitated. A whole colony was built for them, including a school. In the early days, many of them had not gone beyond Kalasa, the nearest town some 25 kilometers away. Even this trip to Kalasa was for the limited purpose of obtaining salt and kerosene. With a lot of costly equipment being used all over the site, and with thousands of men working, the need for security arrangement was not overlooked. The Central Industrial Security Force was entrusted with all aspects of security of the project. The authorities of the project kept monitoring the progress of the project constantly. The chairman and MD, along with the other directors, paid regular visits to the site to keep in touch with the progress of the work. One of the main hazards that the project faced was the ferocity of the monsoon. The area has a total rainfall of 7,000 millimeters for 4 months between May and September. Though there may be other places in the world receiving greater rainfall, it is distributed throughout the year and not concentrated during 4 months as in Kudremukh. This makes Kudremukh the 3rd wettest spot in the world. It literally cuts down the working period every year to 8 months. So, the 4-year construction period for the Kudremukh project really meant 32 months of effective work. While the Lakhya Dam was being built in 1978, the monsoon turned out to be particularly ferocious. The rainfall was some 8,700 millimeters that season. Streams of water rushed down from the mountainside all around. The rainwaters threatened the half-built dam. The temporary spillway that was built had to be breached in order to save the dam and the township. Despite all these hazards, work went on. The damaged portion of the Lakhya Dam was repaired and restored. It was completed on time, as scheduled, without any dislocation of the normal work as planned. The dam was inaugurated by the then Steel Minister of the Government of India and the Chief Minister of Karnataka.
In the
nearby port at Mangalore, work went on to expand the facilities to enable cargo vessels to berth. This work was entrusted to the Mangalore Port authorities. Dredging operations were commenced by the Dredging Corporation of India in 1976. They had the task of dredging nearly 16 million cubic meters by 1980. This would provide berthing facilities for ships up to 70,000 tons dead weight. The new port facilities are designed to ship a total of 10 million tons of iron ore annually. Alongside, on the shore, a steel structure comes up for filtering facilities. Here, the slurry would be filtered and the ore concentrate separated and dewatered for being loaded into the ships. The project undertook building of living accommodation for its employees in Mangalore also. Some 250 residences were put up. Aspects of the project is the form of transportation of the iron ore from the ore site to the port at Mangalore. Early pilot studies had indicated that the transportation of the ore in slurry form would be the most economical way of transportation. This was possible because of the gradient between Kudremukh and Mangalore port. This form of transportation was found to be far cheaper than transportation by road. The cost of a railway would have been staggering, but laying the pipeline to carry the slurry posed a challenge of no mean magnitude. The job was entrusted to Dorsal. The pipeline had to pass through a mountain. The task of cutting the tunnel through this mountain was entrusted to Asian Techs Private Limited, Cochin. The work on the 1.7-kilometer long tunnel started from both sides of the mountain and was completed in 400 days with dead match between the two sections. This passed through a rain-soaked forest, crawling with leeches and snakes, not to speak of wild animals. There was not a single accident or injury during the construction of the tunnel. No mean achievement, this. The total length of the pipeline is about 67 kilometers and passes through the dense Bhagavati forest. The pipe laying is done by mechanized equipment, which enables laying of 1 kilometer of pipeline a day. This pipeline is the first of its kind in India and the third longest in the world. While the project work was on, political changes in Iran resulted in jeopardizing the resources for the project. The government of India stepped in to take over the entire financial responsibility, and the men on the job went on to complete the project on time. In the meantime, the different components of the project were growing steadily and steadfastly. The crusher houses with their major portion underground than on the surface. This would be the place where the mined ore would be crushed and transported to the Monsoon stockpile by conveyors. A connecting conveyor system was put up to convey the crushed ore at the rate of 6,000 tons per hour to the Monsoon stockpile, 813 meters away. Monsoon stockpile complex has a capacity to store some 500,000 metric tons of ore. From outside, it just looks like a huge circus tent made of steel. But the real activity goes on beneath. A vibrating grizzly screen will separate the fine and coarse ore, and the ore thus separated is conveyed to a transfer tower and then on to the concentrator plant. All this was built by the Hindustan Steelworks Construction Limited. The concentrator plant is the heart of the project. It is here that the crude iron ore is beneficiated, that is, enriched to produce concentrated ore containing 66.5% iron. The most modern methods of construction were used for putting up this plant. For example, for the pile work, normal piling rigs were supplemented by an imported one with a telescopic arm, which could bore to a maximum depth of 42 meters. This saved some 4 months in piling work. Alongside the concentrator complex, there are 8 giant concrete drums, which are known as silos. 4 of these silos are 42 meters high, and the other 4 are 36 meters high. These silos are cast by imported slip-form equipment. This is operated by a centrally controlled hydraulic system, consisting of jacks of 6 tons and 3 tons capacity. This enables continuous construction to the extent of 4 to 5 meters height every day. As the workers gain experience, they are able to complete 1 silo in 9 days. In order to provide quality concrete at remote locations, mixers were imported from USA. This obviated the need for establishing numerous concrete mixing stations, and this led to considerable saving of time and money. The smaller size silo has a capacity of 8,000 metric tons of coarse ore. The bigger silo has a capacity of 10,000 metric tons of fine ore. The decision to separate coarse and fine ores before concentration is a result of the tests conducted in the pilot plant. Back on the mining site, entire hillsides in the mining area were covered by crisscrossing haul roads. These roads were able to take very heavy loads, like gigantic drilling rigs, massive electric shovels, and trucks. They were specially reinforced with stone aggregate up to 3 meters. The roads, 25 meters wide and covering an area of 5 square kilometers, were built by the company itself. The assembly of mechanical equipment at site, a time-consuming process. So, in order to save time, all equipment needed for the project was obtained in as near an assembled form as possible. For example, ball mills came from Japan in a single piece, each weighing 80 tons. Likewise, various parts for the autogenous mills, shovel components, and other equipment were all imported in bulk segments. The transport of all this heavy equipment to the project site was no problem, thanks to the new road built between Mangalore port and Kudremukh. The main concentrator building involved a number of intermediate floors and slabs. Since construction with conventional formwork would have entailed delay, a system of left-in-place formwork was evolved. This form was termed Q-deck and was fabricated indigenously and utilized to great advantage. The processing of ore, beneficiation as it is called, in the concentrator involves the separation of iron from other substances in the raw ore. First, the raw ore is ground in large mills, reducing the ore size to 1/20th of an inch. The ore is of two types, magnetic and non-magnetic. Magnetic separators segregate the magnetic particles in the raw ore. But the non-magnetic particles have to be separated by a different process. This is called spiral concentration. The principle involved is that of gravity. The non-magnetic ore, being heavier than the other material in the raw ore, gravitates to the bottom and is thus segregated. Both the magnetic and non-magnetic concentrates are then reground in ball mills before being pumped through the slurry pipeline to Mangalore. Meanwhile, sophisticated computer equipment was flown in from abroad. All the operations at the project, from mining to the loading of ore into ships, are controlled by a large computer process control system. While the system was supplied by Foxborough Company, the application engineering was conducted by a team of Kudremukh engineers. The computer prints out periodic production, running time, and control reports on a fast printer. It interprets operator commands and executes startup, shutdown, and changeover sequences. If the main system fails, a second level of distributed program control system takes over automatically and maintains effective control of the entire process. And maintenance shops were set up and readied close to the mining area. This was to ensure prompt and speedy service of all vehicles and cut down on job delays. Classification of stores was made a streamlined service. Within minutes of a spare being requisitioned, it could be made available. Alongside the growth of the project, the welfare of the workers had received a special priority. A regular township with more than 2,000 permanent residences had been built with all amenities, including facilities for recreation. Modern schools for the children. A full-fledged hospital equipped with modern facilities, a hostel combining in itself the facilities of an attractive clubhouse, a recreation center aptly named after the late P. Sampathayanga, the pioneer geologist. Another notable feature of the project has been, as a public sector undertaking, its concern for its employees. Even as the project was underway, it not only built its own corporate office, but provided on ownership basis to its employees nearly 100 residential units in Bangalore, built on a cooperative basis. The project, which worked on a countdown basis, was ready for commissioning on time. Mining operations begin with drilling of 17-meter holes at the mining pits on the ore body. They are fed with explosives in slurry form. All is set for blasting. The blasted ore comes to the crusher house for crushing. There are 2 such crusher houses. On each crushing unit, supervision is done by closed-circuit television. The crushed ore moves on to the Monsoon stockpile. From there on to the silos, it moves as fine and coarse ore. This was done on August the 13th, 1980. The coarse and the fine ore are conveyed to the concentrator for recovery of the initial concentrated ore. concentrated ore in the form of slurry is conveyed through the pipeline on its way to Mangalore port. This was on August the 22nd, 1980. 7 hours later, on the morning of August the 23rd, 1980, at 7:15 a.m., the slurry was received at Mangalore port. It was filtered, dewatered, and was ready to be shipped abroad, absolutely according to the planned schedule, a worthy achievement that the nation could be proud of. All this precision and perfection was made possible by the computer process control system. It is a symbol of efficiency of the builders of this magnificent project. Karnataka has always been known for the splendor of the sculptures left behind by the builders of yore. The ruins at Halebeed speak eloquently of the temple architecture of the ancient Jains. The giant statue of Gomateshwara at Shravanabelagola is a marvel of sculpture which attracts people all over the world. The Channakesava temple at Belur is known the world over. Today, the Kudremukh Project is no less a monument to the skill of the people who have made it possible. If sculpture and architecture held sway during the ancient times, today their place has been taken by science and technology. What was a rain-soaked virgin forest has been converted into a modern township, bristling with activity to harness nature's gift in the shape of iron ore. Unlike the ancient builders, the modern builders of Kudremukh have come from all parts of the country, from north and south, east and west. They belong to different religions. What has brought them together is a common endeavor. Kudremukh is ranked as the largest new industrial development in the country in terms of capital investment. It is one of the world's larger new iron ore projects of the past decade. What has been remarkable about the project is its completion on schedule under difficult conditions, and what is more, within the budget. In fact, there was a saving as against the original budget. Kudremukh is a saga of skill, courage, and determined effort.